So Deep was showing me some of the feedback from the earlier session that we gave on this, and the one bit of feedback from the tweet was 300,000 words in one session. Now I need a break. So I have about 295,000 of those, and Deep has the other 5, so bear with us. So Deep and I made an observation at last VMworld. What we noticed is that whether we had customers that had a single branch, maybe somewhere in the US, or branches throughout the world, they always tended to ask us the same questions. And basically, well, the meta question is, how do I deploy my vCenter? But it comes in a lot of different flavors. For example, they'll ask me, for my environment, should I use one vCenter? I have a bunch of different data centers. Should I use many vCenters? If I do have a lot of multiple sites, should I use a vCenter on each site? Within a given site, should I be using linked mode? And even something like, should they be using linked mode across multiple sites that are geographically distributed? And when we realized that people had all of these questions, we decided, well, let's try to address some of them. So that's what we're going to try to do in this talk, is sort of help teach you. We're going to try to educate you on what the various trade-offs are so you can make the decisions for yourself. Because for as many people as there are in this room, that's how many different vCenter configurations are. And I can't look at any one person and say, this is how you should do it, and this is how you should do it. So by way of introduction, my name is Ravi Sandarajan. I'm in the performance group at VMware, and I specialize in vCenter performance. And I've worked on the product for about 7 years. So that encompasses vCenter 1.0 to now, and encompasses a full head of hair with no gray. And Deep is a product manager, and I'm going to let Deep go ahead and introduce himself briefly.
Hi. I'm Deep. I'm a product manager in the vCenter, in the cloud infrastructure team, and responsible for a lot of the vCenter stuff, particularly linked mode, multi-VC, multi-site, essentially, helping customers that have a large number of vCenters. And when we started off, I guess 3-4 years ago, most customers had 1, 2, or 3 vCenters. Day before yesterday, I met a customer who had 67 vCenters. So when you have vCenters, from 15 to 20 to 60 vCenters, managing those vCenters becomes an issue. So that's why we thought we'd kind of have this session and talk about some of these deployment scenarios.
So I guess the overall theme is that, just like the saying, if I give you a fish, you eat for a day, but if I teach you how to fish, you'll eat for a lifetime. That's what we hope to accomplish with this talk. We're hoping to teach you how to fish so that even if we don't answer your precise question, you'll at least know where to look. Now, I should point out that in teaching you how to fish, I'm a vegetarian, so I'm screwed, but hopefully it'll help you. So first, I wanted to sort of have a slightly interactive segment here. How many of you feel like you understand the internals of vCenter? And I love that the VMware employees aren't raising their hands. That's hilarious. But, okay. The second question is, do you feel like you want to know about the internals of vCenter? That's awesome. I'm really glad to hear that, because that's kind of what we're going to do with this talk. Do you use linked mode? This is, again, very awesome. Do you know about linked mode, but you don't use it? Okay, that's kind of cool. Deep will meet you outside of the baseball bat. And finally, would you like some guidance as to when you should use linked mode? Okay, this is perfect. So the deal is that a lot of the first couple of questions, since I'm an engineer, I'll talk a lot about the internals and the guts of vCenter. And from a product perspective, Deep is going to talk about what successful customers have done with respect to when they've deployed linked mode and how they've deployed their things. So we hope to give a good mix of theory and practice. So the common questions that we hear, and I hope that by the end you'll understand some of these, understand how to address some of these. Customers will always ask me, so I've dealt with lots and lots of customers. I've seen a lot of different deployments. I've profiled a lot of vCenters, and so I'm sort of culling this from my collective experience of 7 years of dealing with vCenter questions. So a lot of people ask, what's the size of the vCenter? How many hosts and VMs can I actually manage? I know you have limits. What can you actually manage? How many clients can I actually attach? And by the way, you've got API clients, C# VI clients, and web clients. What's the difference in terms of what they load the VC server with? And if I'm using third-party tools or extensions, what impact are they going to have on vCenter? So the title of this talk has to do with distributed geographies. And one of the reasons that we're going into that I'm going to start off with a deep dive into vCenter architecture is that you can deploy one vCenter and manage hosts throughout the world. We have plenty of customers that do that. Or you can deploy multiple vCenters for other various reasons. So in the first part, if I help you understand how the internals of vCenter work, you can maybe understand whether that's the right model for you. In the second half, when Deep goes over what different customers have done, then you can look at that and say, well, maybe I should be doing that instead. So what I hope by the end of my 30 minutes and 295,000 words is that you will understand this picture, okay? We'll go over it in excruciating detail. And basically, it's going to be divided into roughly 4 parts. How vCenter talks to ESX hosts, a little bit about the database, a little bit about the vCenter server internals itself, and then finally what various clients do when they interact with the vCenter server. So let's go ahead and get started. It's a deep dive, but this is Revy. Don't confuse me with deep. So you start the infrastructure, obviously, with a bunch of ESX hosts connected to some storage, whether it's SAN, iSCSI, or whatever. And they're obviously connected to a network, to the vCenter server. The vCenter service itself is named VPXD, so if you see that in any of these slides, that's what it's referring to, just the service on the vCenter server itself. So let's talk about how ESX hosts talk to vCenter. Basically, there's 3 main interactions, the 3 main reasons that ESX hosts talk to vCenter. First, statistics. So obviously, every so often, I'm going to say basically every 5 minutes, a group of hosts is selected to send their statistics information to vCenter, which then funnels it over to the database. So if you ever wonder why you see spikes in network, it might be because of that. Another thing that ESX hosts communicate with vCenter, basically every 10 seconds or so, they tell vCenter, this is my state of the world, and then vCenter looks at their state of the world and says, oh, you know what, I'm behind. I better get more information from you. When it does that, it goes and sends a message to the host, and the host goes ahead and packages it up all the recent changes and sends it back to vCenter. So even though the hosts are telling the status to vCenter roughly every 10 seconds, on average, hosts actually only have any kinds of material changes. For example, maybe a VM's memory usage goes up and down in some way that violates an alert. Those things typically only happen every couple of minutes. If you've ever had the misfortune of having to look at our log files and you've ever wondered what the host sync, you may see that throughout the log files. That's what this process is. This is basically getting an ESX host and vCenter on the same page. And like I said, that occurs asynchronously. On an average setup, it pretty much happens every few minutes. So even though a host communicates every 10 seconds, it doesn't actually have to transfer changes as more frequently than every few minutes. And busy environments obviously have more traffic like that. The final thing is, well, obviously command track. If you're powering on VMs or cloning VMs, your client will send a request to the vCenter server. The vCenter server will send it to the ESX host, and then the vCenter just basically goes away. The only other interaction it has is when the periodic task updates are occurring from the ESX host to the vCenter server. So that in a typical installation, this is kind of an interesting thing. First of all of this traffic is compressed, so we don't end up taking a lot of, well, God help us, but we don't take a lot of bandwidth. But many customers are understandably concerned about what the stats traffic is going to be, but it turns out that in most environments, update traffic is actually quite a bit more, because you're talking about an update every few minutes, a couple hundred kilobytes of changes, as opposed to a couple, maybe tens of kilobits of data for statistics. So it's kind of an interesting thing. It depends, however, on your environment, of course. So why did I bring up this slide? I brought up this slide because we're talking a bit about vCenter and distributed geographies, and so people are wondering, well, would it be okay for my vCenter to be in Atlanta and my ESX host to be in Kuala Lumpur? There is a white paper that was written a couple of years ago where we did a bunch of studies to say what's the impact of variable latency and throughput. So we considered satellite links and dial-up and whatever. And it turns out that for most operations, the vCenter to ESX interaction is more sensitive to the overall latency versus the throughput. So the commands that are, so if you take a look at power operations, remember that most operations basically go to vCenter, send one small request to a host, and then the host does most of the work and then comes back. That's why, in theory, most things should, largely be unaffected by that latency. And I realize your mileage may vary. Things that are definitely affected, however, are clearly the remote console. So when you want to view a VM, obviously that's going to go directly to the host. So if you have a slow link, you might see slower performance there. If you're looking at real-time statistics traffic, in other words, you go to the past hour charts, that is always sent directly to a host. And so if your vCenter to ESX link is slow, then those pages will come up more slowly. But in general, most browsing, and I'll talk about this later, when you're browsing through the UI, unless you're explicitly connecting to a host to do configuration, most of that stuff is satisfied completely at vCenter or at the database. And so the vCenter to ESX latency shouldn't be a problem. But like I said, in a lot of our testing, it was the latency that was the bigger problem versus the throughput. Now, by way of a best practice, one of the things we tell people, and this has been around for a long time, where we say, you definitely want to separate vMotion traffic and even perhaps iSCSI traffic from your management traffic. Now, hopefully, understanding the vCenter to ESX interaction, you have a pretty good idea of why we say stuff like that. Because if you're doing a vMotion, which is going to consume a lot of network bandwidth, at the same time you're trying to do commands, well, those commands themselves might be slowed down because they're trying to share the same pipe. And we've also had other customers that have done iSCSI traffic, and sometimes they'll say, sometimes I click it, it takes a really long time to get some information. And you always want to ask them, well, was some event occurring at that time that would have been taking up the pipe and taking network bandwidth away from your management traffic? Now, a common question that I get is, well, how much do I need? And the unfortunate thing is that burstiness is the rule rather than the exception in vCenter. Now that you understand the three basic interactions, I can show you this chart where I show you, in a sample environment, obviously your mileage may vary, what does the bandwidth look like? As you can see, it's very spiky. In this case, it's sort of megabits per second on the y-axis and time on the x-axis. It's spiky. Every 5 minutes you see a spike, and that spike is basically 10 times what the average is. So even if and this is a very common thing that people will say. They'll say, my network is not saturated, my CPU is not saturated, everything is okay. And to that I say, hey, you know what? Averages are, in some sense, kind of meaningless. You really have to look at those peaks. So if you're seeing a problem, think about when you're seeing that problem and examine things at that point. Don't sort of just take an aggregate average and say, there must be something broken. No, that's usually not the case. One final thing. Remember that I said in the previous slide that one of the interactions between an ESX host and vCenter has to do with statistics. And the way that works is that the ESX hosts are subdivided, and in a round-robin schedule, the hosts these groups of hosts are contacted to get their statistics information. The implication here is that if you've got a slow link between vCenter and ESX, then it might take a longer time to get the statistics for a slow host. And so sometimes if you're wondering where's the statistics data for this host, well, maybe your host that you really wanted stats for was actually stuck behind a really slow host. So it's usually not a problem, but it's just something I thought I'd warn you about. So it's kind of important to keep that in mind. Okay, so now that we have a basic understanding of how ESX and vCenter communicate, let's go over to the database. So we've got our basic picture from before, and now we're going to focus just on the database. So the database primarily is responsible for persisting vSphere information, and I'll get into that in the next slide. And as you all can imagine, statistics processing. So specifically, here's what happens. Whenever you do a task in vCenter, you basically go to the database and archive information about that task. When the task is done, you go and make sure that the database is kept up to date with any configuration changes. So essentially, every task on some level flows through the database. Okay, thing one. Thing two, I told you that ESX hosts talk to vCenter, send it information, and then when vCenter detects that there's a change, vCenter will go to those and say, hey, tell me what just happened. Well, when the ESX host sends its information back to vCenter and initiates this host sync process, that requires going to the database, archiving a bunch of information. So the hosting process is actually composed of a network transaction to the host as well as a database transaction. So you can imagine if you have a very dynamic environment with not just configuration information changing, but certain types of runtime state changing, you're going to have a lot more updates. You're therefore going to see more database traffic. And it turns out that this sometimes causes contention for various database tables. As I said, the frequency depends not only on the dynamic nature of your environment, but it also depends on how frequently you're doing tasks, because every task is going to archive information to the database as well. Now realize that both the database and statistics are sharing the same database instance. So with that coupling there, that's why you might see problems. When people say, oh, I turn it up to stats level 3 and sometimes I see performance issues, well, it's because you're sharing that database instance and sharing the spindles, sharing the CPU, sharing the memory on that database with other tasks that are actually on the critical path of various operations. So what does the database do with respect to statistics? Well, vCenter sends the database statistics pretty much about every 5 minutes. Like I said, groups of hosts are selected, and those statistics are sent from vCenter, and those are sent to the database. And that's a vCenter-to-Database interaction. If you have ever looked in the log files, like I said, I hope you don't have to do that, but if you do, and if you've ever noticed temp table messages, what that is that your vCenter is sending the information to the database into a temp table, and then the database is responsible for reorganizing that data where it actually needs to be. Which brings me to my next point. It's not just stats insertion, which is obviously write-heavy, but there's also roll-up of stats. As you all know, you're converting from past day to past week to past month. And that's occurring on a schedule, and it's essentially, I'm simplifying, but it's essentially completely driven by the database. Here again, averages are incredibly misleading. I'll get into that in a minute, but what you're probably going to notice, or what your DBA is calling you and saying what's going on, is every half an hour there's a roll-up that's occurring. In addition, every 2 hours there's a roll-up from past week. So the half hour is past day to past week, 2 hours is past week to past month, etc. So that's why you're going to see peaks at various times. And they occur kind of one after the other. So that's why sometimes you see a multiplicative effect. And that tends to be, again, very IOPS-centric. Finally, the third main thing that the database is responsible for is that, let's suppose you have a past day statistic and it's been in the database for longer than a day, well, then it gets purged. Purging happens to be incredibly write-heavy. So if you were to look at these three things, you'd probably see a lot of reads and writes from the first two, but you'd see a ton of writes from the third, from the purging process. And this is sometimes the reason that your database admin or your storage admin will call you and say, well, what's all this IOPS traffic for? Of course, and these are all stored procedures within the database, load stats, proc, and purge, and all this kind of stuff. So if you've ever looked at your database stored procedures and wondered what they were, that's what they are. Now, there are obviously other things that are going on. For example, vCenter every once in a while does some queries to get some storage information, and that causes some long-running queries on the storage tables. In addition, there are top-end computations. If you've ever wondered, what are these top-end stored procedures in my database? Well, basically, every once in a while, I think it's every 5 minutes, but the database will compute, what are the top-end VMs by CPU latency, CPU utilization, or something like that. And so if you've ever gone to the overview chart in the VI client, the performance tab, overview chart, and you see that HTML page with all of those charts, so at the bottom of some of them, you see top-end. Those are computed by this database query. So, if burstiness is the rule rather than the exception, let me show you an example of the order of magnitude of burstiness. Here I show you IOPS per unit versus time, and you can see that, again, averages are incredibly misleading. On average, this guy's maybe doing 2K IOPS, but when it's at its peak during a purge process, it's doing 20K IOPS. And the interesting thing is that we always tell people to sort of over-provision for memory, and I'll get into that in a little bit. But if you're doing a lot of write traffic, sometimes memory can't help you because those things have to be persisted. So that's something just to be aware of. It might be helpful to consider using SSD, and I know we publish limits as to what our database sizing should be, but to be honest, we always do that with the minimum in mind, and it's for large environments tends to need to be quite a bit more. I will give an example of that later on. Turns out we did a white paper a couple of years ago. It's due to be refreshed, but in that white paper, one fellow in my group went through and he quantified for different stats levels what the minimum memory requirements should be for different database sizes. It also has different tips. If you're running an Oracle, and maybe there's another white paper for that, but if you're running on Oracle, maybe you want to use separate table spaces. You definitely want to do the standard thing of separating data files and transaction logs, etc. All of the stats processing is very transaction log heavy. So if you've ever wondered why is this growing so much, it's probably because of those routines. Okay. We've talked a bit about the database in some sense in isolation because the roll-ups are more or less occurring in a self-contained manner, as are the purges. Let's talk a little bit about vCenter talking to the database. And on some level, we've already talked quite a bit about this. So we're just going to take a look at what's in this circle right here. So there are three main reasons that vCenter talks to the database. I may be repeating what I said earlier, but I hope that in repeating it sort of brings the point home a little bit more. Clearly, the past day statistics are sent from an ESX host to vCenter, and the vCenter is just basically a pass-through to the database. Then vCenter is done with stats, essentially. So the insertion of stats is one thing that vCenter talks to the database about. Number two, like I said, when a configuration changes, when various runtime state changes, and ESX has to notify vCenter, vCenter again has to persist those to the database. When you have more tasks, clearly more changes are occurring, you're going to see more traffic. And this leads to the phenomenon that when it's then vCenter is very busy, you try to log in and you try to boot around on the client and you think, well, why is this so slow? Well, if some queries have to be satisfied by the database, well, and if it's going to be taken up by doing this other processing, that's why you might see slowness. And that's why, quite frankly, we encourage you to look at our minimum limits as in fact, a minimum guideline. I just mentioned this, but most UI queries, and I'll get into this a little bit more later, are satisfied completely by vCenter. Unless you're doing a real-time statistics query, which of course goes directly to the host, for the most part, vCenter answers everything. If it's not in vCenter's cache of information, however, the request has to be funneled to the database and back. So that's why I'm saying if different database operations are occurring and you're playing with the UI, then you're going to sort of be possibly observing the results of these variable interactions. By the way, I noticed a lot of pictures, and I think these slides are given out after, so you don't have to furiously hope you get a picture before I flip through. Okay, so let's talk a little bit about best practices. And this is, again, a nice thing for distributed geography kind of a consideration. So people will say, what's more important, ESX to vCenter latency? In other words, should my vCenter be in the same data center as my ESX hosts, or can it be in a different data center? What's more important, that latency or the latency to the database from vCenter? And I'm going to say that the latency to the database is, in my studies, and I should point out, I'm not going to, this is not like some VMware gospel, it's more my experience. The latency to the database is far more critical. The reason is that virtually everything goes through the database on some level. Your UI queries, persisting changes, etc. And so if you have a choice, please put vCenter and the database in the same geography. Of course, there are questions as to whether they should be on the same host or on different hosts, and I'll get into that in a little bit. So the point is you're going to put them together, and let me give you a little bit of it's again, a qualitative thing that I did. I was doing some studies where I said, okay, what's the cliff? How far apart can they be before I'm going to start noticing that there's a difference in throughput or latency? And for me, when I put vCenter and the database 10 milliseconds apart, I started seeing issues. So if you're the kind of person that has a vCenter that's connected to some database cluster, it's often helpful if you don't put a lot of layers of switches between those two, because that's going to cause general slowness. The trade-off about whether to put the vCenter and the database in the same host or on different hosts ultimately comes down to your ability to segment their resources. So for example, we do all of our testing in VM, so we put the database in one VM and vCenter in a different VM, and that allows us to independently control, and much, much more importantly, it allows us to over-provision the database disk to give it a lot of IOPS. So that's one level of control. But clearly, if you have some 16-core box in a medium-sized environment, there's going to be enough CPU to go around for the two of them. You're going to minimize the latency, but please don't make the mistake, even in that setup, of giving a poor disk setup, because you're going to be in a world of pain. Okay, so we've talked a bit about ESX hosts. We've talked a bit about the database and how vCenter talks to the database. Let's dive into the guts of what's inside of that vCenter server. So the deal is that in the distant past, every request that you made from a client or whatever would go to this VPXD process, and that was the end of it. And that includes extensions like Converter or Update Manager, etc. But we've added a lot more services, and with those services, we've added a lot more processes to the vCenter server. For example, like I mentioned earlier, if you have ever gone to a host or a VM, gone to the Performance tab, and clicked on the Overview page, you are talking to the Stats Reporting Service, SRS. Okay? So the implication of that is that if you don't right-size the Java heap for that, you might see problems with going to that pane. In addition, we also have a storage management service. If you've ever gone to the VI client, clicked on the storage view, you are talking to SMS. Again, if you don't give that enough JVME space, you might see slowness. The other thing that the SMS service does is it periodically sends queries to the database to collect statistical information about data stores. So every once in a while, your DBA might call you and say, what on earth is this storage-related query? It's probably that. So those are all within Tomcat. I'll show you a screenshot in a minute. But the point is that if you've ever wondered what is this Tomcat process and what's it doing, it's that. It's those processes. Okay. We've also introduced what we call an inventory service, and this is used both for linked mode as well as for certain portions of the UI and for our next generation client. So, like I said, in the past it used to just be VPXD, this vCenter process, but now we have a number of other services that are giving value but also taking up resources, and we just got to be blunt about that. Because of these new services, provisioning the vCenter server, especially with the right amount of memory, but CPU is also important, this is absolutely critical. Let me show you a screenshot of my vCenter. Again, your mileage may vary, but notice that now you're looking at this and you're like, what are all these processes? I used to just have VPXD. One of these Java processes, if you're running our web UI client and you've installed the app server on the vCenter server, that'll show up as a Java process. I've already talked about Tomcat, which is where SRS, SMS, and other various services are. Okay? There's also this inventory service, which, like I said, it helps with linked mode and it helps a bit with certain kinds of UI queries. That's another Java process. Finally, we have other services like PBSM, etc. When you go to the Service Control Manager, you'll see a bunch of different services related to vCenter, and in many cases, a lot of them map to a Java process. Big thing I want to point out here is this is my little piddly setup, and these things are all taking quite a bit of memory. That's why, unfortunately, the vCenters that you may have used in the past, you tend to have to sort of upgrade what your hardware requirements are for that. I also want to point out something that can be very misleading. A lot of times I get a call from a customer and they'll say, oh, this Java process, it's taking 1.6 gig, I think it's running out of heap. And they're running a small environment, so I'll tell them, you know what? It's actually a little bit counterintuitive. See, the thing is this. If you have a big environment, you clearly need a lot of Java heap space. But think about the way JVMs work. JVMs, you give them memory. They're not giving it back. That's just the way it is. So if you have a small environment and you give this JVM a lot of memory, you're going to end up eating a lot of memory for essentially no gain. So in those situations, you might actually be safer just reducing the amount of JVM heap space. Having said that, there's other services where with a reasonably sized environment, it really does need that memory. You might have to tweak the JVM heap size for that. And you can do that. You can change the JVM sizes for these various things. One final note. I mentioned this inventory service several times. What it's doing, as I said, is helping out with our new web UI as well as linked mode. And this inventory service, it includes an embedded database. Why am I mentioning this? Well, an embedded database clearly needs some memory, but even more importantly, it requires disk I/O because it's persisting things to disk. So in the past, vCenter used to be the kind of process that didn't do a lot of disk I/O because most of that was simply handled by the database. But now that in the vCenter server you have this inventory service which is also doing disk access, it's important to really think about how you're provisioning the vCenter server's disk as well. It's definitely not going to be as write-heavy, and it's certainly not going to be as I/O intensive as the database, but it's non-trivial. So just please keep that in mind. Great. Okay, we have at length talked about the ESX host, the vCenter server, the various services in the vCenter server itself, and the database. Let's now talk about clients, whether you have a UI C# client, you have a third-party client, or an API client that you've written, or if you have our newly, introduced web client. Here's the deal. This web client, it's in the bottom left. Okay, the little blue guy right there. He's talking to a server that I've labeled the app server. Remember what I said in the previous slide. I said that if you're using the web client, you're going to have to install an app server. That app server can be installed on the vCenter server itself. It can be installed near the client. It can frankly be installed anywhere. Okay, it's an independent process. It talks to the inventory service and it talks to the vCenter service itself to get some information. So this is an additional resource that you're going to have to plan for. And what I'm going to say is that that app service, even though it can reside anywhere, it's probably best if it's in the same geographic locale as your vCenter server itself so that it can talk more easily to the inventory service and so that multiple clients can share that same app server. Because if each client had his own app server, you're kind of wasting a lot of resources unnecessarily. Let's talk a little bit about clients for a minute. So here's the deal. The C# client is very hungry. What we have done with the C# client is we try to keep from the perspective of the vCenter server tries to keep every client as up-to-date as possible, all of the latest inventory changes, power state changes, etc. And it's basically pushing those changes whenever they occur. That's why we set a limit on how many C# clients you can attach, because the more clients you add, now that was kind of fun. The more clients you add, the more load you're putting on the vCenter server to keep all of those clients up to date. And it's interesting because it also means that if you have a lot of load on your vCenter server, you're doing a lot of provisioning tasks, then more things are happening, which induces more load on that vCenter server, both in terms of memory and CPU, just to feed those clients. Now, in stark departure from that, the web client is much less eager. What the web client is doing is it's much more lazily retrieving information. The CPU difference between the standard C# client and the web client, as far as how they interact with the vCenter server, is fairly dramatic for two reasons. First of all, it's not eager. It's getting things occasionally. But secondly, the CPU processing that would have been required by the vCenter service itself is in some sense now offloaded to this application server and the inventory service. But in any event, because of the fact that it's not getting information as frequently, there can be up to a 6x difference in CPU utilization on the vCenter server. I'll give you an example. We had a really, really intense setup, and the 100 C# clients that we attached required essentially 12 cores just to satisfy all of the changes that were occurring. When we attached 100 of these web clients, it required like a core and a half. So what I'm sort of trying to say is that if you can move to the web client, it's probably going to reduce the load on your vCenter servers. Now, let's talk a little bit about API clients. So API clients, if they are written well, and I'll define that a little bit more later on, those have fairly minimal impact because most API clients are in some sense very surgical. They want a specific thing, and they want it every once in a while. You know, if you're making a couple of calls a minute, that's fine. When you're doing things very, very frequently, a couple of times a second, or you're asking for tons of information, that's when you get into trouble. So when we publish a limit and say you're allowed to have 100 clients, what we're really kind of saying is, look, nothing is going to break if you go past 100 clients, but your responsiveness may slow down, and clients are not built equally. And as long as it's a well-written client, I don't know what we actually support, but you can go above this 100 number and things aren't going to break. But there is one hard limit, and that is the number of sessions. Anytime you log in a VI client, that's a session. You send an API request, you establish an API session, that's another session. You go to the remote console for a VM, that's a session. There's a hard limit of 500. If you go above 500, you cannot log into the vCenter server. Even worse, if you do not gracefully log out of that session, then the session will stick around until a 30-minute timeout expires. So in this degenerate case, if you have a bad API client, maybe I should go to the bad API client later. But anyway, if you have a bad API client that logs in constantly and doesn't log out properly, you're going to eat up a bunch of sessions and you're going to not be able to log in. So the summary, clients add load. C# client adds more load than the web client because of the nature of trying to give you a very up-to-date and consistent picture as opposed to lazily updating. If you aren't using a client session, it's probably a good idea to log out so you're not inadvertently adding load. A lot of people say, oh, I'm just having clients, I'm not doing anything. But unfortunately, not doing anything from your perspective is very different from not doing anything from vCenter's perspective. Because from vCenter's perspective, hey, something changed, I better tell that client. And he doesn't care if nobody's looking at that client. If you have a choice, like I said, when you install the web client, you have to install a web server. Put that web server either on the same box as the inventory service or in the same geography. That allows other of your web clients to talk to the same service, and they'll all, I guess the way to say it is I could have this web service here and I could have my web client here, but then if this guy has a client, he has to go to me. That seems kind of less efficient than just putting the web service in a common place. It's not a very heavily trafficked interaction with the inventory service, but it's enough that it makes a difference. If you are using third-party solutions, or if you're writing an API command by itself, try to be a good citizen. You don't have a lot of control over what your partners do, but it is a good idea to sort of engage and find out what kinds of database calls are you making. Are you making frequent calls to our database? Certain calls that go to vCenter go to the database. So if they're making frequent calls that are really, really expensive, that's not a good idea. An example would be querying every single event in the system all the time. The initial creation of the filter to ask for that is really, really expensive with respect to the database. And so it's probably better to just specify the 10 or 5 or 10 events that you actually care about. In a lot of situations, we find partners write code where they constantly are querying for data that doesn't really change all that much. For example, how many times do you add a physical CPU to a host? Not very often, so constantly retrieving it is not as efficient as just retrieving it once and monitoring for changes. Finally, there's a lot of different ways to monitor the inventory, and in the past, a lot of our customers have used a database-like interface called a property collector, and unfortunately, because it's somewhat of a complicated API, there's a lot of potential for abuse. We have a simpler API called the Views API, which simplifies the calls that you have to make to monitor an inventory. If you're a partner or you're writing a third-party tool, use this Views API. And finally, the mantra of this client section is, when you're done with a session, log out. And log out gracefully. Now, for those of you that are admins that don't write a lot of code using, say, Java or whatever, but you're just using PowerCLI, I need to warn you that it's very easy to be a bad citizen even using PowerCLI. And I'll give a really degenerate example, but let me explain the theory behind the degenerate example. PowerCLI is very easy to use, and partially that's because it offloads a lot of work onto the server, and partially because it splits some of the work that the server should be doing at the client side. So the deal is, whenever you do something, you're retrieving a bunch of information, and then underneath the covers, the client, once the PowerCLI client gets that information, it throws away what it doesn't need and then gives it to you. So it often retrieves more data than it actually needs. To give you an example, when you do get VM, you're getting information for absolutely every VM in the infrastructure. When you do a get VM call with 4 VMs in the command line, you will get information for every single VM in the system, and then on the client side, everything but those 4 VMs will get thrown away. So it is better to specify something like this, get VM with the 4 names listed like that, rather than setting up a list, iterating through that list, and doing get VM on that VM, because each of those is going to get all the information for every VM and then throw away everything but the one that you want. That's being a bad citizen. Whenever I get someone that calls me and says, I'm running this PowerCLI script and it's taking 24 hours, that's the first thing I look for. The second thing I look for is whether they're doing getstat, because there's a lot of ways that you can write getstat much better than the way it's usually implemented. Also, please log out when you're done. Okay, everybody take a deep breath. We are done with this slide. I hope this was in some way somewhat helpful. Was this helpful? I'm really, really glad. Let's do a little bit of summary now. Hopefully you now understand what happens when you attach extensions. Basically, they're monitoring for inventory changes or for whatever, and if you are seeing a lot of activity from them, you want to go and ask your partner, hey, what kinds of calls are you doing? Did you qualify that with VMware before you did that? And I try to talk to them all, but hey, there's just me, so what are you going to do? In addition, if you've ever wondered, what is this Tomcat process? Why is it hogging up so much memory? And can I lower it or should I increase it? Now you have some understanding of what's going on there. I hope you also understand why we set limits on hosts and VMs. Like I said, burstiness is the rule rather than the exception. So on average, you're not going to need many resources, but when you need them, you tend to need lots of them. And when we set our limits, we're saying, well, above a certain point, you're probably going to see responsiveness issues. So we recommend, probably is perhaps the wrong word, but you know what I'm saying. It's important to keep that in mind. And An extremely common question, hey, you publish a limit of X, Y, and Z. For our largest customers, they'll come back and say, I'm not able to achieve that. Am I doing something wrong? This is such a common question that I thought I'd put on my bulletproof vest and actually answer it. So here's the deal. This is how we set limits. We create a large environment, 1,000 hosts, 10,000 VMs, that kind of thing. We attach all of the clients or solutions that we want to qualify with. For example, if we want to say that we support 100 clients, we'll attach 100, 150, whatever many clients we'll attach. Then we'll run a boatload of management operations. The average customer's environment does 1/100th of the load that we're inducing when we do this. So we really stress all of the points within the vCenter server itself. And when we're doing that, we're measuring the latency and throughput and looking for a cliff there. Now, why won't your setup necessarily reach our scale? First of all, it's a very controlled environment, but there's basically at least 5 different reasons it might not match. Number one, something incredibly simple like the device configuration or the configuration, for that matter, of your hosts and VMs might make a difference. To give you an example, if my setup has all hosts that are 4-core and your setup has all hosts that are 16-core, you have automatically quadrupled the number of stats that you're going to see. That right there will have a performance impact. If you have 35 data stores per host and I have 3 data stores per host, by the way, data stores are in some sense the most statistically consuming part of the database. Anyway, 35 versus 3, that's like 10 times the number of stats. These are some of the reasons you're going to see problems just based on configuration. If you have a different database configuration, we like to over-provision when we're doing performance testing. It's kind of like doing a benchmarking run. And if you're sort of trying to lower the limits and get to a good minimum point, perhaps that is not quite provisioned enough. Or if you're using a different recovery mode like full versus simple, which of course a lot of customers do. If you have a different network topology, if your vCenter and your database are far away, you're going to see a different behavior than we see. If your vCenter and ESX hosts are really far away and it's different from what we do, things like stats or whatever are going to be slower to show up. Even something as mundane as viewing a different client page is going to cause different behavior. Like I said, you go to the storage view page, you're causing a database query, and you're going to the stats reporting service. Maybe I'm just looking at the data center summary page, which essentially does not make any calls to the vCenter server, except extremely rarely. So what your clients are doing is going to impact the load that vCenter is going to see. Finally, another thing that sometimes customers need to keep events for 3 years for auditing purposes, and in our case, we might purge it after 180 days. There's a setting in vCenter to do that. That's another reason. If those tables are accumulating, with time, your database performance might slow down, and therefore your vCenter performance might slow down. Now, because I've said over provision like 40 times in the last 2 slides, let me give you 2 samples of what we tested with. Again, not the VMware gospel, but I just wanted to give you an understanding of what's going on. So in one sample environment where we were testing 1,000 hosts and 10,000 VMs, we had a vCenter server with 16, we run everything in VMs, so it's 16 vCPUs and 56 gig of RAM. It's a lot, I realize, but we're over-provisioning. We're being incredibly conservative there. We were using local storage, but it's high-speed local storage. So even though we have the embedded database there, we're able to handle that. And we're running Win2K8. If you're not running Win2K8, I frankly highly recommend that you move to Win2K8 from Win2K3. What about our database? The database that we were using in this particular test was an Oracle database with 8 vCPUs and 26 gig of RAM. More importantly, we were using 15 spindles, and we separated data and transactions across 6 different volumes. We've got a really great DBA to help us with that kind of stuff. Our hosts were between 4 and 8 cores, and the VMs were between 2 and 4 cores, and most of those hosts had local storage. Yours is probably going to have a lot of shared data stores, perhaps many more than we might have. I called it the DM server. I should have called it the app server. When we were deploying our web client, it talks to the application server. For that application server, we way over-provisioned it. We gave it an 8 vCPU VM with 8 gig of RAM, but in practice, we could have given it half a core and only 512 meg, and it would have been just fine and dandy. And we were able to attach up to 100 VI clients. Like I said, vCenter is much more, in certain ways, I think it's more memory sensitive than CPU. So if you have to make a trade-off, more memory is often much more helpful. Finally, everything was on the same network switch, and we were at stats level 1. So obviously that's going to have a huge impact on what kind of scalability you can reach. Let me give you another sample configuration. This is number 2. for 32 hosts and 3,200 VMs. We again over-provisioned the vCenter server with 16 vCPUs, but you know what? We only used 2. We gave it 26 gig, but we only needed about 12. You have a lot of different services there. They need memory, but they might not need it all the time. For the database, typically you want to over-provision anyway, and we gave it 8 vCPUs and 12 gig of RAM. This time we were able to run it on local disk instead of the 15 spindle arrangement from before. We didn't have a lot of VI clients in this particular setup, so we didn't have to worry about client traffic. And we were again at stats level 1. So, you can see the spectrum here. In one case, we have 32 hosts. In the other case, we have 1,000 hosts. But the memory requirements are kind of on the same order of magnitude, and CPU was quite a bit less. So, to summarize the last, 40 minutes, vCenter's performance depends a lot on how it's provisioned, whether it's the database, the vCenter server, or even something like the ESX hosts. As an example of that, we were talking to a customer a couple of months ago where they upgraded vCenter and they upgraded the ESX host, and they said, hey, all of a sudden vCenter's a lot slower. And we were like, well, what does it mean it's slower? Well, all of our cloning, power on, all of those operations were slower. And when we did a bit of digging, what we found out is that when they upgraded their ESX hosts, they didn't upgrade the driver to the storage appropriately, and so their storage was actually slower. That's not vCenter's fault. It's not storage's fault, but the point is, when you're doing power-ons and clones, which are storage-intensive, those are going to be slowed down, and it masks itself as if it's a vCenter slowness problem. And think about the rule the exception rather than the rule, as in think about burstiness and try to understand what your environment is doing at its busiest times as opposed to trying to look at an average. And of course, it depends on how it's used. If you attract a lot of clients, if you put a large amount of latency, now you understand what implications these have on the performance of the vCenter server. Now, because stats is such a popular topic, I'll spend a minute on statistics. A lot of customers want more stats, and to do that, they want to increase the stats level. And in a lot of our documentation, we say that can increase the load, that will increase the load on the database and can have performance implications. We're working on these kinds of issues. Obviously, I can't give you a timeline, and I put up the disclaimer slide for that purpose, but we are acutely aware of those issues, and we're rewriting a lot of our procedures and queries to be much more scalable. In the interim, a lot of times what I ask customers is it an option for you to write a script that will get some of the real-time data? If you get the real-time data, you don't have to go and increase the stats level. If you need help with stuff like that, I'm more than willing to talk with you about that offline. And finally, should you be using ESX top and just scraping data all the time? No. ESX top can have a performance impact on an individual host depending on how loaded that host is. If that host has 100 data stores, ESX top can take a lot of resources and really impact things. And the better way to do things is really to do it programmatically using our API. Now, let me give you some rules of thumb if you want to know what is the impact of increasing stats levels. Again, this is not the VMware gospel. This is me making qualitative observations. What I have seen in various environments is that when you go from level 1 to level 2, you can expect at least a 1.5 times increase in how much stats are being generated, which then translates into more network bandwidth and more transactions to the database and more database activity. The big jump is level 2 to level 3. That's 4x. So think about it. If you go from level 1 to level 3, you're increasing the amount of stats by a factor of 6. It's kind of like you're managing a 6 times larger environment. And level 3 to level 4 is actually a fairly minor jump. So level 3 is the one where we have to be really, really careful. And I was reminded this morning that we do have an API for changing the stats levels of various statistics, but you have to be really careful about that because if you just wantonly do it for everything, you're going to end up with the same performance problems that you had as if you increased the stats level in the first place. Your mileage may vary. Okay, now that I've taken up my allotted 295,000 words, it is time to hand it over to Deep, and Deep's going to talk about some practical customer scenarios and how they've made the trade-off between one vCenter, multiple, linked mode, etc.
Thanks, Ravi. So now that Ravi's gone through the gory details, this will come across as very simple. So as we talk to customers, we find out about a lot of the deployments that they have, and I'd just like to talk to a few common deployments that we encounter. Let's talk about single-site deployments. So obviously, if it's a single VC, everything that Ravi spoke in gory details applies, and you know all about it now, right? But if it's a very common deployment is you have a single site with multiple vCenters. And so when is it that you need a second vCenter? Well, obviously the first one is when you reach the scalability needs of the scalability that can be handled by a single vCenter. I've spoken to a lot of customers. I have one customer who has infrastructure separated based on its use. For example, they have a separate vCenter to handle all federal workloads, and another vCenter to kind of work their use for their regular workloads. So oftentimes it's not vCenter scale that's an issue. Before that, the customer needs to split their resources and have multiple vCenters. So organizational compliance, security, and those kind of reasons. In fact, those are more often the reasons why you have more than one vCenter or multiple vCenters. So the other thing to ask is, so I was meeting a customer, and he said a very funny thing, which was the first time I heard that. Said, my boss wants to see everything on a single window. He doesn't really care about it, but his boss wants to see. So, and I've come across other customers where, they want to be able to see a lot of everything that's going on in a single pane of glass. If view is one thing that you're really concerned about, being able to see all your vCenter activities or all your vCenters from a single VI client, that's something to keep in mind. The other thing is, you might have a scenario where you have multiple vCenters, but it's the same set of administrators who are working across all of these vCenters. So you have the same set of roles that you'd use in one vCenter, the second one, and the third one. If both of these are important to you, then that's where linked mode comes in really handy. So if you've never used linked mode, this is a bad screenshot of how linked mode actually looks like. So essentially you have a whole bunch of vCenters on the left pane, and you can point to whichever vCenter you want to kind of work on and go to the details of that vCenter. So as I said, the first thing linked mode does is provides you a single pane of UI. The other thing that linked mode does is it allows you to query or search across vCenters. Let's say you have 10 vCenters, and that probably translates to 15,000 or so VMs, and then you're looking for a VM. Instead of trying to find out in which vCenter it is in, if you can just query for that VM, and the underlying query infrastructure will kind of federate across all the VCs and get you the data. Again, the other thing we mentioned was, you can have unified roles across vCenters. You create a role in one vCenter, you can see it in other vCenters. Obviously, you need to apply that role to a person, to an identity and an object to create a permission out of it. But at least you can see the roles across all of the vCenters. All right, so this is kind of a pictorial representation of linked mode. So what are the things to consider in linked mode? Well, the first is that linked mode works currently with only 10 vCenters. So can I have a show of hands as to how many folks would like to use linked mode only if it supported more than 10? Supported more than 10? Okay. The other one is linked mode uses a technology called Atom replication, and Atom does not work on Linux, and that's why linked mode currently does not work with vCenter on Linux, the appliance that we shipped in 5.0. Linked mode does not support cross vCenter operations, so that's not possible. And the other thing to note is that APIs are not linked mode aware. If you make an API call, it has to be against a certain VC that you want to talk to. So a little bit of detail into the architecture of linked mode. So you have a single vCenter out here with its database and managing a bunch of ESXos connected to Active Directory, its own Atom, and connected to an inventory service. You have another one and a third one. So what gives you the query federation or the ability to query across all of these vCenters in linked mode is that the inventory services are actually connected. And what gives you the role replication is Atom. Essentially, if you create a role in one vCenter, it's replicated across the three. Okay. So now that we've spoken about a single site deployment, let's look at multi-site deployments. So that's another very common scenario that our customers have. Oftentimes, it's simply because they have data centers at multiple places. So in this situation, one thing to consider is where are your system administrators located? I mean, we have customers where all of the administrators are located in one place, but they have data centers located in multiple places. And obviously, in some other cases, you have, depending on the time of the day, administrators manage from a certain geography. So I have a customer who has data centers in New Jersey, UK, and in Singapore, and depending on the time of day, different set of administrators kind of start work and manage all of the infrastructure. So if your administrators are spread all across the globe, then I guess you need good network bandwidth between the sites. Whereas if administrators are located close to the vCenter, across sites, bandwidth is not an issue. The other thing to consider is if one of the sites is a backup for the first site, then performance is not as critical. So you could very easily have linked mode across multiple sites. So, for example, in a large bank, they have this fixed private equity, and that department has data center kind of pods in multiple data centers, and they own their own vCenters. They have their own set of administrators, and they want to be able to manage those in a uniform way. So that's when they create a linked mode across those vCenters that span New Jersey, UK, and Singapore, let's say. So what are the important considerations here? Well, the first thing, obviously, if you have a business justification, you want a single pane of glass, even though it's spread across multiple sites, and that's the reason why you'd link them. So what impact does bandwidth have? So the only additional thing that linked mode adds to bandwidth is the Atom replication, and Atom replication doesn't really consume much in terms of bandwidth. So linked mode really does not add too much in terms of, it does not hog additional bandwidth. So, the usual bandwidth trade-offs that occurs in VCs across multiple sites without linked mode apply to ones with linked mode. That's pretty much what happens. So, and again, the local admin versus remote admin, that issue what happens. For example, if you are on linked mode viewing 10 vCenters, and not all 10 of them are located where you are, then you'll see a slow performance with the vCenters that are remote. Okay. So the other very common deployment is what we popularly call robo deployment, remote office, branch office. But what I've realized is it's not just remote office, branch office. Oftentimes our customers have sites, smaller sites that have 20 to 30 ESX hosts, but not a vCenter in that site. The other more popular one is, so we have a retail customer who has 2 ESX hosts at every store they have, and they manage it from 2 central data centers where they have vCenters. I have another customer that I know of that has a lot of hubs in South America, and they manage all of those ESX hosts in those hubs from a data center in Miami that has 2 virtual centers. So these are very common deployments that our customers have. And so the impact of low bandwidth on this, we have a white paper that was published, and if you haven't read it, we'd recommend that you go through this paper. So one of the things is, if you want to push patches and updates and things like that, these customers tend to do it at night when the traffic is low, right? So that's one of the things to consider. The other important thing is within each site, the bandwidth between the ESX hosts needs to be high so that the vMotion for high availability and all of that stuff can still take place. So these were some of the common deployment scenarios that we spoke about. Ravi, you want to go to the next thing? So let's summarize. We're going to talk about the performance of single vCenter. All that. Yep.
Yeah. So we're just going to wrap it up. This is pretty much the next to the last slide.
Right.
So just to sort of, is this mic? Okay, good. Just to bring it all together, A lot of customers ask, can I deploy vCenter with hosts throughout the globe? The answer is absolutely yes. Now you know all of the trade-offs. The bottom line is really think carefully about how you provision your vCenter and really think carefully about how you use that vCenter. If you're doing a lot of tasks, you might consider splitting up your environment across vCenters just so that they can achieve higher operational throughput, for example. Provisioning is the rule. Your little 2 vCPU, 4 gigabyte vCenter server instance from before might not be enough this time because of a lot of the extra services. After I spoke a bit about the single vCenter, Deep went ahead and talked a lot about multiple vCenters. It might not be technology decisions. It might be based on policy, some organizational boundaries or things like that. Deep has a great example regarding security and compliance as a reason to go ahead and split multiple vCenters. You want to go ahead and
just finish it, right? So obviously the reasons, as I said, were beyond the scalability limits. It had to do with organizational boundaries, security and compliance, location of your administrator, and then the reasons for having linked mode. If you want a single view across your vCenters and you have roles that you can share across multiple vCenters, that's when you'd have linked mode. So these are the technical resources that, if you want to kind of look further at some of the performance studies that we've done in the white paper.